Hello everyone, welcome back. Now, we will talk about the case that the location of origin must be changed, shift to somewhere else in order for us to find the intercept with the axis. Now, there's two cases that we will understand that the location of origin is not possible to find the intercepts, or we understand that the location of origin must be shifted to somewhere else in order to find the intercept. Now, we did B, type of B. We're looking at A. I'm looking at finding intercept for, this is the origin, and we want to find the intercept of plane A with the axes A, B, and C. Now it's very easy to understand that we cannot find those three intercepts. Why? Well, look, this plane passes through origin, yes? Passes through origin. It means that it intersects x-axis with the 0, intersects y with the 0, intersect z with the 0. With 0, 0, 0. 1 over 0 will be infinity, which we have to, it's not the way that we're representing plane, we have to shift this origin from this corner to somewhere else. So the first case that we know that the origin is not at the right location, it is when the plane is intersecting the origin. If the plane intersects the origin, you have to shift the origin to somewhere else. So this is not going to be an origin for me. For B, it's okay. For B, there is no problem. But for A, to find Miller indices for plane A, this is plane A we're talking about. For plane A, we have to change the origin from here to somewhere else. Now, where to put this origin? We said we had 8 corners, yes? So here cannot be used. The 7 remaining, 1, 2, 3, 4, 5, 6, 7 other possibilities we have. 7 other possibilities that we can take origin to any of those corners. But let's say that why some of them will not be applicable. I'm going to choose one of them, then we'll tell you that why is not applicable. So, let's see, we're going to choose, let's say we're going to choose this corner here. Let's say this is going to be origin, and that's going to be the axis y, x, z. Now remember, when we draw the axis here, x, y, z, imagine also they're negative also here. This is y negative, and this is x negative, and it's going to be z negative. Now let's look at A. Look at the plane A. Where does it intersect x-axis? Where does it intersect x-axis? Now this is the x-axis they have. This is the line of x-axis. Do I know where does this plane intersect x-axis? Now many of you may think of this point, 2 over 3. But this is not the axis. This is not the location of the axis. The axis is here. When we say intersection with the axis, the point is supposed to be on this line here, whether on the positive side or the negative side. For example, for Z, it's okay, yes, this is on the line. Look, this point is on the line. Yes, this is okay for Z, but this is not for X. Why? It's not going to be true, this one, because this is the x-axis, the line. Again, for y-axis, well, I don't have plane A does not intersect with y-axis. Even not parallel. It's not parallel. If it was parallel, okay, but it's not even parallel. So since it's not parallel, and I cannot find the intersect. Why? Because of the location of origin. It's not suitable, so I know that this cannot be the right location for origin. I mean, we don't have, this plane does not have intersection with those lines. Like with the 6th line we have it here, 24Z, 24X, 24Y. It does not have intersect with those lines. Let me tell you which one is the right corner, then you will understand. Now let's use different color. Now if I bring origin to this point here, this is going to be y-axis, this is going to be x-axis, and this is going to be z-axis. Now remember, you have 3 more axes as well. There's also a part of the axis y-axis, there's a part of z-axis, look, and this is a part of x-axis. Now let's see if we have direct intersect of the plane with the axis. This is y, this is x, and this is z. Well, the intersection with x, I'm looking at the line, whether the positive side or the negative side. I have somewhere here. Look, this point now, it's on the axis. So I can take this one as x-intercept, which is capital A, will be 2/3. Now, intersection with y-axis. This is y-axis. So whether this part or the other part. If you see that there is an intersection on the y negative, on the negative y, which is the corner of the cube, it's on the negative y, it's acceptable. So intercept with y-axis will be -1. Will be -1. Well, with the z-axis, you can see it as well. You can see it with z-axis. So whether the positive side or the negative side, you see this point is on the axis. It's on the axis. So intercept with z-axis will be 1/2. It's in the positive, on the positive x-axis. Sorry, positive z-axis. Positive z-axis. So now look at them. The 3 points, the intercepts, are on the axis. So this is the right location for origin. This is the right location for origin. Try any other corners, you will not find it. You will not find the intercepts, all of them, to be on the axes. So you have to be careful. Locating the origin for plane, it's very crucial. You have to find a location that the intercept will be on the axes. Well, if it's parallel, nothing can be done. If it's parallel, nothing can be done. So now converting those to HKL, HKL. This will be 1/2/3. For this 1/(-1). For L will be 1/(1/2). Well, for the first one, for H will be 3/2. For K will be -1. For L will be 2. Now we say we have to get rid of this fraction, so multiplied by 2 here, multiplied by 2. Then will be 3, when this plane A is 3 -2, 4. 2 times 3/2, 2 times -1, 2 times 2, and this is the plane of A, 3 -2, 4. So why do we change the origin? Because the original first given origin had an intersection with the plane. So there was an intersection exactly at the origin, so that's a must. You have to shift the origin somewhere else. So you're gonna shift origin somewhere so that you will find intercepts easily. Intercepts easily. That we did it here for you, and then we're changing them to HKL, the Miller indices, and we ensure that there must be integer numbers. There must be integer numbers. Now, those are okay. Let's look at another case that we have to shift origin. Now look at plane B here, plane B. Now if this is the origin, let's see that what will be the problem with facing it here. Now intersect with x-axis, we have it is right here. If this is the origin, I'm not changing the origin now to see if they have a problem or not. This is intersect with x-axis, which is half. So we're writing intersect with x-axis, it's 1/2. Now intersect with y-axis. Well, this plane, this edge and this edge are parallel to y, yes. So we know that there will not be any intersect. It's parallel. It's parallel to y. It's parallel to y. So I hope you understand what this parallel means. Parallel, it means it's not gonna cut y in any way because the direction is parallel to the y-axis. So this is gonna be intercept at infinity. Intercept at infinity. Then with the z-axis for C, well, now where do you find the intercepts with the z-axis? This is the z-axis. Remember, many students, they imagine the cube, all the cube edge as the z-axis. This is not z-axis. Remember, this is not z-axis. This is not z-axis. The only z-axis we have it's here at the back or below that one. This is z-axis. So do we have it? We know that there will be an intersection. Yes, there will be an intersection because look, it's intersect some vertical, but the z-axis is somewhere wrong. The z-axis is somewhere wrong. Why? Because yeah, it has to be something like this, but this is not z-axis. Yes, so I cannot take this one. I cannot take this one as intersect with z. Well, where does it intersect? If I draw this plane like this, it will intersect somewhere, yes? When we say plane, it's a continuous, remember, something like this. It will intersect somewhere here. Somewhere at the bottom here, it will intersect. It will intersect, but, well, is it going to be minus 1/2? It's going to be minus 1/2. Some of them it's not clear. Some of them not clear. So what we have to do, we will shift the origin to somewhere that we can find the intercept easier. So we're gonna cross this one. Why? Because we cannot find a direct intersect with the z-axis. So I'm crossing those three. Crossing those three. We will shift the origin and we find the intercepts easier. Now, where do we choose the origin? Remember again, this takes some knowledge. We will keep x-axis here, y-axis, bring it here, and we'll put z here. Look what I did. I brought z here so that this point will be on z. I had problem with the z, yes? So look now, this time is on the z. I can say this is intercept with z. With x, what happened? It's still on the x, but in the negative side. On the negative side, and on the y, it's still parallel to y, so it's not gonna change anything. So it will be a intercept with x-axis. Remember, you have to find new intercept. This will be minus 1/2 because it's on the x-axis negative side. So minus 1/2. Well, with y, it's still intercept with y, it's at infinity because it's parallel. Well, now intercept with the z-axis we can find because it is here. It's intercepting the z-axis as you see it from there. So it is somewhere here, which is going to be, it's given to us half, 1/2. Now changing those to HKL, HKL is going to give us the plane's indices. So 1/2, I'm just writing it will be minus 2. 1/infinity 0, 1/1/2, it's going to be 2. So this plane, it's minus 2. This plane is going to be minus 2, 0, 2. Minus 2, 0, 2. Again, for this one, you have to shift the origin. I have to shift the origin, and by practicing, you know where is exactly you have to put the origin. I need you to try those two cases when the origin must be shifted in order to find the intercepts with the axes. Then you will go to find HKL. Now, we will explain drawing these planes in the next video. You have to practice more in order to understand how to find, but the basics are still the same way. Find the intercepts and then convert them to HKL, the Miller indices, by taking reciprocal 1 over A, 1 over B, 1 over C. Thanks for watching.